Okay, today is 8.3 day one. This is actually a pretty important one, so that we're going to work on. We're going to start working on our multiplication. Of course, if we can multiply well, then we can divide a lot easier. So that's why this is really important for us to look at. There are two things that we're on techniques we're going to work on today. One of them is using distributive property to multiply a polynomial times a polynomial, and the other one is use the box method. I don't really highlight the distributive method, and I'm just going to show you just a taste of the box method. Um, the distributive property works for everything. The box method is just another way of showing the distributive property. I allow you to choose this, but honestly, I'm going to try to I'm going to use the distributive property almost exclusively in class. So that's kind of the way I'm going to lead you and steer you towards for these. So here's a use of distributive property. So what I end up doing is I'm going to multiply this binomial times this binomial. So I take 2x times 3x. And then I take 2x times negative 7. Now that I'm done with that, I'm going to take 4 times 3x and 4 times negative 7. Now, I write it down here just like how when I did the arrows above, I put it above, the arrows below, I put it down below. The reason that I do this is so that when I start to combine things, they end up matching up. So that helps me to figure out what I need to do next. So 2x times 3x is 6x squared. And 2x times negative 7 is negative 14x. And 4x times 3x is 12x. And 4 times negative 7 is negative 28. And so now that I've gotten this all multiplied out, I'm going to add these up. And this comes straight down. Negative 14x plus 12x is 2x. And this comes straight down for my answer there. Okay, now the reason why I line these up is so that I know that these two are like terms and they've lined up as like terms, so that's why I do this. It works out a little bit easier for me. You can do it horizontally, but this is how I'm going to continue to show you. So in this one, same type of thing. I'll take x times 4x to get 4x squared. X times positive 3 to get positive 3x. I'm done with the x. It's gone to both of them. So now I'm going to take negative 6 times 4x to get negative 24x. And negative 6 times 3 to get negative 18. Add these up. I get 4x squared minus 21x minus 18. Again, using distributive property to do this. This one, same thing. I really like to put my arrows in here to help me know what I'm doing. X times x, x squared. Remember, you just add those exponents. X times 6 is 6x. 3 times x is 3x. 3 times 6 is 18. X squared, 9x, 18. Now, what happens if these two things don't match up? Then I don't put them on top of each other. I leave them a little different, little space there. But as long as they line up, I'm going to keep them there. It really works out nice. So x times 2x times x is 2x squared. 2x times 3, 6x. Negative 5 times x is negative 5x. Negative 5 times 3 is negative 15. Add these up. To get my answer there. Same problem, same type of problem, same structure. Again, I'm going to do it above here. So that's what I've gotten so far. Now I do below. X times that is 7x. 7 times 4 is 28. X squared, 11x, 28. Now this one is a little different. This one is a binomial times a trinomial. Still don't do the same thing. Still don't use that distributive property. So I take x times x squared, which is x to the third, x times negative 3x, which is negative 3x to the second, x times 1, which is x, or 1x. Now I've taken x to everything, so I'm good with that. So now let's do the other one. 5 times x is 5x squared. 5 times negative 3x is negative 15x. 5 times 1 is 5. Again, I have them lined up. X to the third, 2x squared minus 14x plus 5. The reason why I like this distributive property, it really doesn't change. It really helps me to make sure that I line things up, making it a little bit easier so I keep these correct. Again, this is a binomial times a trinomial, so I expect 3 multiplications. X times x squared is x to the third. X times 3x is 3x squared. X times negative 4 is negative 4x. I feel like I'm done there. This x was multiplied by all 3, that's good. X times 2 times x squared is 2x squared. 2 times x is 6x. 2 times negative 4 is negative 8. There we go. Okay, now this particular problem drives me crazy. This one's written upside or backwards. Now, for me, you could take this times here, but that seems like that's a lot of multiplications. I don't like that. So I'm going to still follow my same pattern. I'm going to take the short one times the big one. 2 times 3x squared is 6x to the third. 2 times x is 2x squared. And 2 times negative 5 is negative 10x. Now I move to the next one. Negative 7 times 3x squared is negative 21x squared. Negative 7 times x is negative 7x. Negative 7 times negative 5 is positive 35. Add these up. To get my answer. Now the only thing that's weird about this one is it's written backwards. You could have rewritten it, putting this one first and then done that, but again, I'm kind of lazy in that regard, so I'm just going to multiply and use my arrows. I really like my arrows. So that's how I use the distributive property to do these. Now, let's talk about the box method. The box method, what you do is you make a box. And I'm going to end up putting I'm going to make a check mark here. So this is x minus 3, 4x minus 5. Could they be reversed? They sure could be. Now I multiply these two things. Negative 3 times 4x is negative 12x. Negative 3 times negative 5 is positive 15. So now I put together what I have left. These two get put together. Okay, the box method is very, very similar to what I've been doing. It's not really not that different. The thing that I don't like about the box method is these two things can't be stacked, and so it's hard to tell which ones I'm supposed to get as far as which ones I'm supposed to combine. That's one of the reasons why I really like that the distributive property is I can stack those up. I can decide which ones need to go together. Just showing you another example of this. Again, I start off on my checkerboard basically. my tic-tac-toe board. 3x and 1, x and 4. Okay, so I'm just follow that. So 3x times x is 3x squared. 3x times 4 is 12x. 1 times x is 1x. 1 times 4 is 4. Again, these both have just x's. So I'm going to put the 3x squared first, and I'm going to combine those to get 13x, and that to get my 4. Now, there's nothing wrong with this method. I don't really like to have two to choose from, and I'm much better. I feel like the distributive property just works out a little bit better. So I'm going to continue to use that. And like I say, you can choose this box method. It doesn't make any difference how big the numbers are. The box just changes. But I do think that how many numbers are to change the box. I do think that I'm going to continue to show you how to use distributive property for that. Okay. Hopefully we'll get a chance to see you guys back soon.